Horizontal circle pendulum. Imagine someone holding a string here and this thing going around in a horizontal circle, but it's still a pendulum bob. So how do we calculate this? We want to know maybe how fast the pendulum bob needs to go to make a certain angle happen. So why don't we label this angle theta here. We would be given a length L, and then you could use that to find the radius R, the radius of the circle. So we'll assume that you know how to do that. The R here, of course, is the opposite side of the triangle here. And we do have length L here, so we can just say radius of the circle equals L sine theta. Okay, so that would be trigonometry for you there. Now what about the rest of the forces that are involved? Well, eventually we're going to get to some kind of a centripetal force. But let's take a look. Straight down, we have force gravity. And in this direction, of course, is force tension. Let's break force tension into its components. So we have force tension Y and force tension X. Let's go ahead and label all those now. So this will be force gravity. We have force tension pointing along the string. This will be force tension X. And this is force tension Y. Now the ball is not going up or down. It's just going around in this kind of a circle. Therefore, force tension Y must equal force gravity. And of course, force gravity is mg. Force tension Y must be mg. Again, if we think of this as a parallelogram, it's force tension X as pointing this way, which would be pointing this way for the ball. And in other words, force tension X is acting like force centripetal. Okay, so let's figure out how we get force tension X. Well, the angle theta right here is also located right here. So that angle theta is that angle theta there. Looking at our triangle, we have something known here as force tension Y, and we need to find force tension X. So we can use the tangent of theta, because the tangent of theta is the opposite side of a triangle divided by the adjacent. So let's write that over here. Tangent theta is going to equal force tension X divided by mg, because mg is what force tension Y is equal to. So force tension X is going to equal mg times the tangent of theta. Okay, so going on to this side here, we can set force tension X equal to force centripetal. So mg tangent of theta is going to equal mv squared divided by r. Let's see what crosses off. The m's will cross off. And why don't we solve for the tangent of theta? So tangent of theta is going to equal v squared divided by gr. And that could be our base equation then for a horizontal circle pendulum, as long as you have the angle theta, and of course we assume that you would find the radius based on the length before starting the question.